Feed the wrong video path into ComfyUI, and the old transcoder could decode every frame into float32 tensors before saving. Longer clip, taller pile, larger RAM bill. ComfyUI version 0.29.0, released July 29, 2026, changes that behavior with streaming video transcoding and packages the fix beside several broader model and training additions. The save system has two routes. A compatible source can be remuxed through stream copy. A source needing conversion enters the transcode branch, the route this patch rewrites. When the source already matches the requested container and codec, remuxing can copy the stream. The expensive behavior appears when ComfyUI must actually transcode the media. The pull request says, partner nodes uploading video, hit the transcode path whenever the source is not already H.264. That makes codec choice a direct trigger. Codec is not the only trigger. Video slice forces transcoding for any codec, so trimming or cropping a clip can expose the same old memory problem. Inside that old branch, the entire video was materialized as float32 tensors. This was not merely a queue of compressed packets, it was expanded frame data. The pull request estimated peak memory as twice the frame count times width times height times 12 bytes, about 47.5 MB for every 1080p frame. Because frame count sits directly in that estimate, duration becomes dangerous. Double the frames, and the old transcode buffer estimate doubles with them. That scaling explains why longer transcoded videos were the painful case. The workflow was not just processing more frames, it was retaining the growing collection in memory. Version 0.29 rewrites the transcode branch as one streaming pass. Instead of building the whole tensor mountain, it advances media through a fixed sequence. First comes demuxing. The container enters, and its media streams are routed into the pipeline. Nothing here requires every future frame to wait in RAM. Next, compressed video packets are decoded. The crucial change is cadence. One frame proceeds onward instead of joining an ever-growing full video tensor collection. The decoded frame is reformatted inside the same pass. The pipeline works on the current frame, then hands it forward rather than preserving the complete decoded history. Then, the frame is encoded toward H.264, while audio can be encoded as AAC. Each completed unit keeps moving. The pipeline does not await the final frame. Finally, encoded video and audio are muxed into the output. Demux, decode, reformat, encode, and mux now operate as a connected streaming chain. The phrase that matters is one frame at a time. A frame enters, moves through, and leaves before the pipeline advances through the rest of the clip. The merged pull request states that peak memory for this transcode path no longer scales with video length. More frames still require processing, but not a proportionally taller buffer. So the before and after is simple. The old path retained a video-sized frame collection. The new path maintains a moving working set through the transcode chain. Memory was not the only cost. In the pull request's load video to save video benchmark, roughly 75% of old wall time was attributed to conversion overhead. The reported chain was YUV to float RGB into torch tensors, back to RGB, then back to YUV. That conversion ping-pong powered both the memory and speed problem. Treat that 75% as the pull request's benchmark observation, not a promise for every machine or workflow. The reliable architectural claim is the streaming memory behavior. This was not supposed to discard useful behavior. The pull request says trim windows remain sample exact for video and audio, including trims chained together. The tests also cover portrait rotation, 10-bit handling, bounded audio, and workflow metadata. Streaming changes the transport mechanism without simply ignoring those media details. Here is the sharp boundary. The pull request explicitly says eager tensor materialization in get video components is a separate issue, and this patch does not address it. This release item targets the RAM buffer in video transcoding. Its sources do not claim lower GPU model memory requirements, so do not translate this into a universal VRAM fix. If a model, latent, or another graph stage exceeds available memory, streaming transcoding cannot rescue it. Version 0.29 removes one length scaling bottleneck, not every possible bottleneck. The direct win belongs to workflows that actually transcode, especially longer non-H.264 uploads and video slice operations, where the previous buffer grew with every decoded frame. But 0.29 is bigger than one memory patch. The official release also combines video training support, Gemma 412b, Joy Image Edit, and other additions. A merged training pull request adds video dataset loading and processing nodes, letting ComfyUI's training pipeline receive video data through purpose-built graph components. Image processing nodes were also changed so that when they receive video, the same transform can be applied to each frame as an individual image. Training nodes now support video latents with 5 dimensions. That is the structural change the pull request identifies for carrying video data through training. Put those pieces together. Load video datasets, process their frames, represent video latents, and feed supported training nodes. ComfyUI's graph is extending further into dataset preparation and training. The release also adds native support for Gemma 412b text generation. That puts another text model directly into the set of workflows ComfyUI can support. The verified pull request makes a narrow claim: support for the new 12b model for text generation. It does not provide performance promises in this source packet. Joy AI Image Edit receives native model support, and the integration includes a Qwen3VL module because ComfyUI did not already contain the dependency the model needed. Its contributor describes Joy AI Image as supporting image understanding, text-to-image generation, and instruction-driven editing, a 3-part loop now wired into native ComfyUI support. The release notes separately label additions for providers including OpenAI, Google, HeyGen, Anthropic, and others as partner nodes. Do not silently recast those entries as native local models. Update for the streaming transcode fix if video workflows matter to you, but keep expectations scoped. One nasty RAM multiplier is gone. The rest of your graph still counts. Subscribe for the next reality check.